Hello everyone, hope you all are fine. Today we will be starting the hydrogen chapter, that is the second inorganic chapter for class 11. We have already done redox, and that's I hope you all are revising the ion electron method. Basically you are practicing, many are there. So today we will be starting the hydrogen. We have hydrogen S block and P block also in the half yearly portion. I guess you all have seen the half yearly portion, and also you all have seen the reduced portion. Inorganic chemistry is basically this part which we are starting now. It's inorganic chemistry, that is, it's about the reactions and all. You all are mainly now busy with the organic and physical chemistry. I hope you all have started organic. If not, please do start, do not delay, because that part is really very important. GOC is the most important part of class 11. Just to give you some not advice, I just want to share something that 11, 12, many things are connected, but some chapters that you need to do very nicely from class 11 is chemical bonding, redox, equilibrium, and GOC. These are very much connected with class 12. Rest all are very important, of course. Every chapter is very important. And I forgot the most important one, chapter 1, that is normality, molarity. That's another very important, because that's not only needed for your theory, that also needed for your practical calculations and all. So these chapters that I have said, and GOC is very interesting chapter, the most interesting chapter I find. So we are continuing with hydrogen. In hydrogen presently we have preparation, properties, position of hydrogen, and then we have hard and soft water. I was just checking that in the new syllabus they have removed the numerical which is based on the hardness of water. Then we have hydrogen peroxide as one compound of hydrogen, their preparation properties, and then I think strength of hydrogen peroxide. That was it there again in chapter 1. You all have done that. Now, introductory part of hydrogen, if I say hydrogen chapter you had in class 9, so you know that hydrogen is an element which shows dual nature. That means it has certain properties of metal and certain properties of a non-metal. Hydrogen can accept electron to form hydrides. That means it can act as an oxidizing agent by reducing itself, and also hydrogen can lose electron to form H plus ion. That means it gets oxidized and it can act as a strong reducing agent as well. Hydrogen's this reducing agent property is very much helpful for the extraction of metal from the ores, from the oxides of elements the atoms or the elements which are quite lower in the activity series, like copper oxide, ferric oxide. Hydrogen can be used zinc oxide, and as oxidizing agent, sodium hydrides, it reacts with sodium to form sodium hydrides, and these hydrides are good source of hydrogen later on. So these are certain dual nature of hydrogen. Hydrogen also, if I tell those points which were there in class 9, like it has diatomic, like halogens, it needs one electron to complete its valence chain, and so on. I'm not repeating all those things. About this preparation of hydrogen, these also I think it was there, like metal is a very important reactant. Metal, when reacts with dilute acids other than dilute nitric acid, it forms hydrogen, and if it is dilute nitric acid instead of hydrogen, we get NO and water, NO2 and water for dilute and concentrated acid respectively. Then hydrogen, if you want from nitric acid, then you need to use magnesium manganese or very cold dilute nitric acid. These all things are again present here. Then amphoteric elements like zinc, aluminium, lead, tin, they react with alkalis to form hydrogen, and electrolysis of acidified water, that gives hydrogen. Also non-metal can be used to prepare hydrogen, like steam, if reacts with white hot coke, we get water gas. From there we get hydrogen through the Bosch process. So these all preparations were there in your hydrogen chapter. Now hydrogen has isomers. It's depending on the spinning of its nuclei, that is proton. If there is parallel spinning of the nuclei of hydrogen atoms in a molecule, then we call it orthohydrogen, and if it is antiparallel spinning, we call it parahydrogen. This is the term that is new here. We'll see a little bit of reaction today, and then next week also we'll be continuing with this chapter as well. Reactions, I know you may find reaction bit of boring, so from now little bit if you keep on reading, it will be not a huge pressure, because inorganic is very small part for class 11 and very expected question only comes, very obvious question comes for from this inorganic part. So every day if you are given half an hour, 1 hour or 1.5 hour for chemistry, so at least alternate days you give 5 to 10 minutes or 15 minutes to inorganic chemistry, but make sure you give half an hour minimum to organic chemistry from the day one, otherwise you will face problem later on. You can tell me how you are liking this chemistry subject. I hope you all are enjoying it. Let's see certain reaction of hydrogen. So let us start our discussion with certain reactions of hydrogen. Hydrogen is preparation, I'm not telling. Hydrogen reacts with nitrogen through Haber's process, as you know, under different conditions like temperature, pressure. So they form NH3, and then hydrogen can react with a different metal directly to form hydrides with non-metals also, and hydrogen can reduce different oxide like copper oxide, lead oxide to form their respective metal. Zinc oxide, ferric oxide, also the metals which are not that much reactive. Hydrogen also has a very importance in the hydrogenation reaction through occlusion, that is in the organic chemistry but that you read in class 10, that triple bonds, double bonds, the unsaturated molecules, they gets converted to the saturated ones by hydrogenation process. For that particular type we need different kinds of catalyst which actually helps to occur the hydrogenation. The catalyst can be palladium, platinum, nickel. That catalyst can be zinc copper couple, on which if you are passing the ethanol vapor, then addition of the nascent hydrogen takes place, or hydrogenations, addition of hydrogen can be done using Lindlar catalyst also, where the triple bonds can get converted to double bond in presence of catalytic poison like palladium and all, which was there in class 10. These things were there. So there's a use of hydrogen. Now if we talk about hydrides, hydrogen can form different types of hydrides. With metals it forms metallic hydrides, as for example sodium hydride, magnesium hydrides. They are formed by the direct combination of sodium and hydrogen, magnesium and hydrogen, where hydrogen itself gets reduced and reacts as oxidizing agent. Similarly covalent hydrides and polymeric hydrides. Now covalent hydrides can be electron rich, electron deficient hydrides, and it can be electron precise hydride. Now electron rich, if I start with electron deficient hydride. Electron deficient hydride means in its Lewis-Strauss structure you will find an empty orbital where the octet is not completed, like boron hydride, BH3. BH3 basically does not exist in this form, it exists in dimeric form B2H6. So BH3 is electron precise because here boron's outer shell has not completed its octet. It has its sextate here, that is 6 electron at its valence shell, so it can be as electron deficient hydride. Similarly, if it is the number of electrons are exactly equal, there is no extra lone pair of electron or lack of pair of electrons, then we call it electron precise hydrides like methane, CH4. It can be group 14 like silicon, SiH4, silicon hydride. They are electron precise. If there are extra electron, that is lone pair of electron present, then we call it electron rich hydride. And then this is another type, electron rich hydrides. Example like in H3 there is one pair of electron which is present here, or water also can be an example, HF can be an example. Now this electron deficient hydrides, they needs electron to complete their octet, so they can be used as some agent which is very good in accepting electrons, and they also known as examples of Lewis acids because they are lone pair acceptor. And also in the organic chemistry you will read about the if you have read about nucleophile and electrophile, philicity means attraction or affection. So these type of molecule, that both BH3 and B2, not B2H6, BH3 here, as the electron deficiency is there, so they are good electrophile, and here as there is electron rich, so they are Lewis bases, because they can donate the lone pair of electron easily, and they also act as nucleophile because they have a tendency to attack the positive centers. So here this part is related to organic chemistry very much. So these are the types of hydrides. This is a very interesting part from here. Next we have polymeric hydride, beryllium hydride. They exist in form of polymers. We call it polymeric hydrides. Next we have the preparation. These are certain important part from here. And then uses of hydrogen, multiple uses, like hydrogen is a very clean fuel because byproduct after oxidation is water, which does not cause any pollution. And hydrogen reducing agents in organic chemistry for hydrogenation of oil, hydrogenation of coal, increases its efficiency as fuel, and so on. So next day we'll be continuing this chapter. Till then, take care and bye.